Okay, so let's talk about the static electricity experiment. We're going to start with atoms. This right here is an oxygen atom. Oxygen atoms have 8 protons. This oxygen atom also has 8 electrons and 8 neutrons. The protons and neutrons are gathered together in the nucleus. Now, like most clip art depictions of science, this one isn't drawn to scale because we know that the nucleus is actually super far from the electron cloud. Remember we talked about how if you were to blow up an atom to be the size of a football field, the nucleus would be in the center, about the size of a tennis ball, and those miniature electrons would be spinning around the football field, orbiting the nucleus in the electron cloud. But that's how far they would be away from the nucleus. It's because of the way that they're charged. Okay, so protons are positive charge. We show positive with a plus sign. Neutrons have no charge. Electrons are negative. We can show negative with a minus sign. Okay? So you might have noticed how things can attract or repel each other. I'll give you an example. On a dry, staticky day in the middle of winter, when your heat is blasting in your house, sometimes your hair seems to grow and each strand of hair seems to repel each other. I'll draw a picture of that. Here's you. I bet you guys miss my artwork. And your hair looks like this. Maybe you just ran a comb through it. Your hair seems to repel each other. Ugh. Don't like that feeling. Or sometimes you had a wool cap on, if it's snowing outside. And when you go to pull it off your head, your hair seems to be attracted to it. That's because of electrons. We're going to end the soda can experiment that we did, as well as the water experiment with static electricity. That all relates back to electrons. Electrons, electricity. Okay, so it comes back to conductors and insulators over here. Let's focus over here now. And then we're going to come back to the atom. Some atoms hold on to their electrons really well. They're called insulators. They don't allow electrons to flow as easily. In order to make the electrons move, you have to apply a force. Insulators do not allow for an electric current. Conductors, however, do. They do allow for an electric current. Metals, water, those are good conductors of electricity. They allow an electric current to flow. They allow their electrons to flow so their electrons move freely. Okay, that's the difference between a conductor and an insulator. Let's come back to the atom. Using our example of oxygen here. Okay, so because electrons are spinning in the electron cloud, they can leave, and it doesn't change the atom at all. The atom is determined by the number of protons. So if this electron leaves, goodbye. The oxygen atom would still have the 8 protons, so it's still oxygen, okay? But when the electron leaves, it's only 7 electrons. Since protons are positive and electrons are negative, that would cause this oxygen atom to be mostly positive. Okay, so on the contrary, atoms can gain electrons. So electrons aren't blue, but I'm going with the clip art picture they have. This electron here could join this oxygen atom. That would mean that it would have 9 electrons and 8 protons. Since electrons are negative and protons are positive, that would make this atom overall negatively charged. Okay. So what we did is we used an insulator. You might have used a balloon if you had them at your house, or maybe like me, you used a comb. Both of them are insulators. They're made of plastic. So that means that they hold on to their electrons pretty well. But when you applied a force, like in my case, I used the glove and I was rubbing it vigorously on the comb, I was causing electrons from my glove there we go. I was causing electrons from my glove. I'm going to represent an electron with a circle with a minus sign in the middle because they're negative, to join the atoms on the comb. When the comb, by the way, if you used a balloon, same thing. Your balloon would have more of a negative charge. So that means that my comb overall has a negative charge. Alright, so then what happened next? My comb, which had a negative charge, was then applied to a soda can. There. When I came closer to the soda can, it was attracted to the positive charge of the soda can. Keep in mind, this comb is pretty negatively charged. So the can that I used was more positively charged. Negative and positive attract each other. That's how you were able to sort of pull the can towards the comb. It was light enough for you to do that. The same was true when we went to the sink and there was water. That water from the sink is more positively charged than the comb, which we charged with more electrons. That caused the water to bend towards the comb. All right. Hope you enjoyed.